So we're solving absolute value equations. That's 1.1. And our very first note is actually the definition of absolute value. So you need to make sure that absolute value makes it somewhere on your paper. And then the actual definition is the distance a number is from 0, and it is always positive. So that's something we need to remember about absolute value, is that it's always positive. So when we say that absolute value is a distance from 0, what does that mean? What is the absolute value of positive 7? 7. What's the absolute value of negative 7? Also 7, right? So even though we have a positive 7 inside or a negative 7 inside, the answer is still the same, correct? That's because all we're doing is counting the number of spaces that is from 0, and we can only have positive distance, right? Distance can't be negative. So that's what that means. So how do we solve equations when there's absolute values in them? So solving absolute value equations is our topic here. We have 3 steps. Step 1 is you are going to isolate the absolute value bars. What does isolate mean? Very good. We want to get it by itself. So I'm just going to write that little note. Get it by itself. Okay, so isolate means we want to get it by itself. That's step 1. Step 2, we're going to write 2 equations and solve. So if I have the absolute value of x equals some number a, that's going to split up into 2 equations. X equals positive a, or x equals negative a. And we just showed that up here, right? The absolute value of 7 is 7, but the absolute value of negative 7 is also 7. So there's actually 2 answers here, correct? So we're going to split it up into the positive and the negative. And then step 3, now we have 2 equations. We're going to solve both of those and check our answer. So I have a question for you guys. Is it ever possible to have an absolute value equal to a negative number? If I'm taking the absolute value of, let's say, x, could it ever equal a negative number? No, because absolute value always makes it positive, right? So I just wrote that note. Absolute value of a negative number is no solution. We have, this symbol means no solution. Okay? So just write that note to yourself. If you ever get absolute value equal to a negative, we can stop. It's no solution. There's no more work that we have to do. So let's look at example 1. Example 1 says to solve for the absolute value of k plus 6 equals 9. Step 1, I'm going to actually bring the steps down a little. Step 1 says to isolate the absolute value bars, or get the absolute value bars by itself. Are my absolute value bars here by itself in example 1? Is there anything attached to them at all? No, we are all by ourselves, right? So we're going to go straight to step 2, write 2 equations and solve. So I take whatever is inside those absolute value bars, and I set k plus 6 equal to positive 9, and k plus 6 equal to negative 9. So I make 2 equations. So we're actually going to get 2 answers here. To solve this one, k plus 6 equals 9, what am I going to do first? Who's in C4? Fernando. What am I going to do to solve this guy? K plus 6 equals 9.
Get it by itself.
Okay, we got to get k by itself. How am I going to get rid of that plus 6?
Move it over to the 9.
Okay, so if I move it over, does that mean I'm adding or subtracting?
Subtracting.
Good, subtracting. So we're going to subtract 6 from both sides. What's 6 minus 6, you guys? 0, so they cancel. So what's 9 minus 6? 3. So I get k equals 3 as one of my answers. And then I'm actually going to do the exact same thing on this side. So I'm going to subtract 6 from both sides. 6 minus 6 gives me 0, so I get k equals What's negative 9 minus 6? Good, negative 15. So I have as my answer k equals 3 and negative 15. And then make sure you put a box or a circle or a highlight around your answer so I know that that's your answer. Okay? Step 3 says we need to check it. How would I check both of these answers? Any ideas? Who's in seat 6? Samuel. How would I check both of these?
Plug in negative 15k.
Very good. I would, for my check, plug in negative 15 and positive 3. So I'm just going to check this problem, and then we're not going to check the others because we don't have time right now. But I do want to show you how to check it. So absolute value of 3 plus 6. What's 3 plus 6? 9. So that gives me absolute value of 9, which is equal to 9. Is that a true statement? Yes. Okay, so let's try negative 15. Absolute value of negative 15 plus 6 gives me absolute value of what? Of negative 9. And what's the absolute value of negative 9? Positive 9. So does that one work? Yep, so both of our answers are correct. Okay? So example 2, we have negative 2 times the absolute value of x plus 3 equals 6. Okay, so I see negative 2 on the outside of the absolute value. I need to get the absolute value bars by itself. So does anybody have any ideas of what I could do? I've seen it done I've seen it done 2 ways. Let me explain both ways to you, and you guys can tell me what's right. First way I've seen is distributing the negative 2 into the absolute value, and then taking the absolute value bars and solving. The other way I've seen is dividing both sides by negative 2, and that gets these absolute value bars by itself. How many of you vote for choice 1, distributing? Okay. How many vote for choice 2, dividing? Good. You guys are supposed to divide. Why don't I distribute? Absolute value bars work like parentheses. They keep everything on the inside together. However, whatever is inside the absolute value bars, that's the distance we're looking for. If we distribute that negative 2 in there, all of a sudden we're doubling the distance of each thing, right? We can't do that. We have to keep it the same. So do not ever distribute. So let's write that note. Do not, underline, distribute. Okay? We never ever want to distribute into the absolute value. We're trying to get it by itself. So we need to get that negative 2 to go away. Since negative 2 is being multiplied by the absolute value, we divide both sides by negative 2. What's negative 2 divided by negative 2? Please don't say 0. When you divide something by itself, what do you get? 1. Good. So these things turn into 1, so it actually still ends up canceling each other. So we get absolute value of x plus 3 equals 6 divided by negative 2. What's that give me? Negative 3. So what do I do next? Who's in 27? Natalie, what do I do next? Okay, so we set it up into 2 equations. Anybody have a different suggestion? What do you guys notice about this one? You're right, except for one thing. What do you notice? That's what she's saying. We split it into 2 and take down the bars.
Oh, okay.
Okay, that's what she's saying. But I noticed something else about this problem. There's a negative. So you both are totally correct, but we're equal to a negative. Is that ever possible? Can we be equal to a negative in absolute value? No. So what's my answer? No solution. So we can stop there. Okay? So you both are doing the problem the exact right way. Just make sure that your note go into kind of robot mode and start going with the problem before you check to see those special cases. So if you're ever equal to a negative, we get to stop. We're done. Does that make sense? So just make sure that you're paying attention to what we're doing. Okay. Any questions so far? Good. Alright, example 3. We have 5 examples. We're almost done. Example 3. Solve 3 times 2x minus 1. What I want equals 45. What I want all of you to do is just do the first step for me. So what am I going to do first? Do it by yourselves right now. Okay, so what would my first step be? 36. Ewa. What would my first step be? Which way is 36? This way. What did you do first? Exactly. We have 3 attached to the absolute value, so we want to get rid of that, so we're going to divide both sides by 3. Remember, we cannot distribute here, so just divide. 3 divided by 3 is 1. So I get absolute value of 2x minus 1 equals, what's 45 divided by 3?
15.
Good, 15. Okay, so I have absolute value of 2x minus 1 equals 15. What would I do next? Caleb. What would I do next?
Take away the absolute
Mm-hmm.
value signs and then make it do 2 different problems.
Good. So I take down those absolute value signs and I make 2 different problems equal to positive 15 and 2x minus 1 equal to negative 15. Now, this negative right here does not change, okay? So please do not change this to a 2x plus 1. This whole thing inside stays exactly the same, okay? So all of this just comes straight down. And then solving this is just a 2-step equation. What do I do first, William? Let's say 2x minus 1 equals 15. What would I do first there? Okay, so he says we subtract 1 from both sides. What would negative 1 minus 1 be? 0? The signs are the same, so what would negative 1 minus 1 be? Negative 2. So what's the opposite of negative 1? Positive 1. So we want to add both sides. 1 to both sides. And we actually do that on both equations. Because then we have positive 1 plus, or negative 1 plus 1, which turns into 0. So that gives me 2x equals, what's 15 plus 1? Good, 16. And then this one gives me 2x equals negative 14. Negative 15 plus 1 is? Negative 14. Okay, so we get 2x equals 16. 2x equals negative 14. What do I do to solve for x? Sarah then. Yeah. So I would divide both sides by 2.